Oh, cool. We are right. We are live.
Nice. I saw more and more people join.
Before we get started, we have a question doc where you can put your questions for Brendan, and we'll have a 15 minutes Q&A at at the very end of the meeting. So that's the link sent to the chat. Hey, Brendan said he's coming.
Whoa.
All right, can you hear me?
Yeah. Hey,
Cool.
Brendan.
Hey there, how's it going?
Doing great. How are you?
Doing all right?
Yeah. Can we start, or do you need a few minutes?
Yeah, I think so. Uh, I uh, I need to pull up my screen share.
Yeah, that's fine.
Yep.
I'm going to give like a very short introduction, and then I will hand it to you.
Okay. Cool. I think we can make that work.
Awesome. I'm going to record a meeting right now. Alrighty. Hey everyone. Welcome to the Splunk Virtualized System Meetup. We are your host. I'm Masaka, and we also have Wen today. It's our pleasure to introduce you Brendan Burns, a corp founder of Kubernetes and corporate vice president of Microsoft, overseeing more than 1,000 engineers on Azure management, cloud native open source projects, Azure Portal, Kubernetes on Azure, Linux on Azure, and etc. Hopefully cover all of them. In fact, I'm in one of Brandon's team. It's called Azure Container Upstream, where I worked on cloud native open source project to bring WebAssembly to the cloud. Before we begin, I want to ask you all to abide to our code of conduct. Basically says, to be nice and respectful to each other. Be a nice human being, please. And folks, if you have any questions or comments, please use the raise hands feature in Zoom, or I put a link to the Google Doc where you can put your questions there. We have a Q&A at the end of the presentation. And Ling and Wen and I will be monitoring the questions for Brendan. All right. So without further ado, Brendan, I'm handing the stage to you right now.
Awesome. Thank you. Thanks for giving me the chance to come speak. I'm going to share my screen. Hopefully it will work. All right. All right. Is that coming through?
Yes.
All right, perfect. I'm going to give a talk today on Kubernetes past, present, and future. Hopefully it'll give you a sense kind of where the project came from, a little bit about where we are right now, and then a little bit looking into the future about where I hope that we are going. I definitely intend it to be interactive. Hopefully it's going to stir some questions and stir some thoughts. And so I'm happy to take those whenever. I just because of the way I'm set up here so that I can look at my slides and stuff, I can't actually see the chat right now. So, Masaka and Wen, if you are willing, just please, if you see a question in the chat that feels like it is good to answer now, feel free to just ping, just say, hey, we got a question or something like that. And I might be able to see hands. I'm not actually sure. I have a little like minimize thing. So if I see hands, I will try and call. And then otherwise, we do have some time at the end for questions as well. Okay.
Sure.
Cool. All right. So I think containers and cloud native kind of have this reputation as being like, they call them digital natives or, new tech. It really has this kind of reputation of new technology. And I wanted to kind of push through that a little bit because actually the roots of what we might call a container are nearly as old as I am, right? And so in 1979, this idea of chroot, which was the ability to change the root file system or the perception of the root file system for a process, was introduced into BSD Linux, or excuse me, BSD Unix. Or into Unix, and then became part of BSD in 1982. And this, I would really argue, is that very first moment when people started to create containers. They started saying, hey, for this one process that's running, let's give it a different perspective of the operating system than every other process. And in fact, multiple processes could have their own perspectives about what the operating system looked like. Fast forward a little bit into 2000, the internet had happened. If you weren't around then, it was a pretty exciting time. But also it was a time when suddenly security was a really big deal, right? So previous to the internet becoming a really big thing in the, let's say mid 1990s, security was important, but it largely had to do with, keeping your physical machine secure as opposed to what somebody could do over the network, talking to your servers with vulnerabilities. FreeBSD introduced this idea of jails as a way of trying to like keep processes in check. I've got a web server. If there's a vulnerability, if it gets exploited, I want to make sure the rest of my system doesn't get exploited. And FreeBSD's jails brought that idea into play. And then in 2005, Solaris, which is a Unix that some of you may have heard of, it was the proprietary Unix supported by Sun Microsystems, and Linux and created this idea of zones. And then in 2006, 2007, Linux C groups and namespaces were added to the Linux kernel. So we're looking at, close to 20 years. And what both zones and C groups and namespaces added was the notion that resource isolation was a valuable thing too. So you've got chroot, which is sort of, I'm going to change what the file system looks like. You've got FreeBSD jails, which says, hey, I'm going to restrict what you can do as a process within the kernel. And then you've got zones and containers and C groups and namespaces, which sort of say, hey, I'm going to maybe try and do resource isolation, limit the amount of memory that you can have access to, limit the number of processor cycles that you can have access to. And then, of course, as it's grown over the years, namespaces have come to encapsulate just about everything that's inside the kernel. In fact, one of the ways I said to people, one of the ways to understand what a container is basically to just think of every variable that you've ever thought of inside of the kernel and then make it an array. So instead of having, one process ID counter, now we have an array of process ID counters and so on and so forth. And obviously each element in that array is one of the namespaces. And then, and then I think this is the important bit, which is that the cloud happened. So in 2010, Microsoft Azure launches. EC2 had launched a little before then. Google Cloud launches a little after. But cloud is an important part of why containers became a thing that they are today. And then the other thing that was really, really important was that Docker was released in 2013. And so hopefully that gives you that's the history that leads up to 2014 when we first released Kubernetes out into the open source world. That's the industry history. The personal history is that in 2012, for the first time, I switched to working on cloud. So previous to working on cloud, I'd been working on distributed systems to do web search. I actually did a PhD in robotics and did a lot of systems work. So it turns out, you wouldn't necessarily think it, but actually doing robotics is a really great grounding for learning the internals of the operating system, because especially back when I was doing robotics, everything was about performance. The better you could make your program perform, the better you could control the robot. And being able to do that meant really deeply understanding the kernel and how it operated, as well as actually we were integrating a lot of random hardware that we'd built ourselves into the operating system. So a lot of work with kernel drivers and kernel modules. And so there's this combination of a bunch of time spent doing low-level systems hacking, a bunch of time spent building distributed systems, and then suddenly in 2012, I switched to working on cloud. And now I don't know how many of you have been involved in cloud computing in 2012, but just to give you a perspective about what I saw when I went there, it was VMs. There were these virtual machines, and I'd done a bunch of distributed systems, but I'd never really used a virtual machine because we'd been doing process isolated containers, we'd been doing microservices, and so stepping into the world of public cloud in 2012, it was suddenly like, oh my God, there's VMs everywhere. They're not very declarative. People are actually managing via SSH. Right? And people are logging into these machines, getting to a terminal prompt, typing apt-get, typing whatever it is to install the software, sometimes running some scripts. And then eventually configuration was saying, like, we're going to do imperative, like even something like Ansible was basically just like a glorified way of running scripts on all of these machines. And a lot of times it was even worse. A lot of times it was just like, I don't know how many of you remember how you installed Docker, but the way you installed Docker was you basically just ran a bash script, and it just like downloaded a bunch of binaries, did God knows what, and eventually things were installed, right? Heaven forbid that you have to do it repeatedly. And so like in general, the world of cloud in 2012 was a pretty darn scary place. And more importantly, not only was it a scary place, but it was a place that was really hard to make reproducible. And the interesting thing about being in this, simultaneously seeing all of this pain, we did a lot of work around, some of my first work in cloud was infrastructure as code solutions. And we would do a ton of work on that, and we'd get a script that would maybe work 97% of the time, right? And that's not great. 97% of the time is not great. But at the same time, even though we had a sense for what was wrong and we had a sense for what could be better, it was really hard to figure out how we would convince the world how they could improve things. And then this amazing thing happened. So in 2013, Docker came along and mainstreamed containers. And we looked at what Docker was doing in terms of getting everybody excited about this container idea. And it was suddenly like, oh my gosh, okay, we don't have to do that part anymore. Suddenly the world is starting to pivot towards containers in general. We don't need to convince people that they might want to use a container. But we can start actually getting people to use something more than just individual containers. And so that's sort of what the moment where we realized, Joe and Craig and I realized, oh, you know what, we could actually do this thing, like this whole open source container orchestrator idea that we've had. It might actually have legs. We might actually make it work. But before we get into sort of, what we were trying to do with Kubernetes, I wanted to dive into like what I saw when I saw the container, because I think everybody at this point has some notion of maybe what a container was, but I think that it is useful to kind of understand the various things that I see a container providing that was truly different than that sort of world that we saw before. So what is a container? Well, I think the first thing that I think of a container for is it's a place to hold all your stuff, right? Again, I want you to maybe throw your mind back to that world of VMs and SSH and certainly the industry when I started. I started building systems in the .com era in the late 1990s. And like just installing all your stuff and keeping it together was like a problem that you needed to solve, right? And one of the most beautiful things that container images did was they basically just said like, hey, like we'll just smash everything together into this one hermetically installable thing. Um, and you want to install it, you just pull it. And if it doesn't work, you just pull it again. And you just keep doing that until it works, right? And so like you didn't have to worry about things being halfway installed. You didn't have to worry about like maybe you forgot to, package up some script at one point or package up some DLL or some .so. Like nothing, it just was everything that you needed, right? And it was built on top of this kernel ABI that Linux had done a really good job of making sure was compatible across a lot of different versions. And so, you could be on an Ubuntu system building because it's nice and pretty and that sort of thing. And you could build your application and run it on your Ubuntu machine, and you could deploy it to a Red Hat machine in production, and it would work. And like that was honestly like that by itself was a value proposition that was worth it, right? And in fact, I think a lot of the early adoption of Docker was exactly just because of that. People were tired of shipping stuff that they built on Ubuntu into a Red Hat system and having it fail because some .so was different or some API was different, right? And the container fixes that problem. But I think it's more than that. I think the other thing to think about is that the container is sort of a class. Like if you think about object-oriented programming, why do classes exist? I mean, they exist in some sense for things like inheritance and things like that. But at a foundational level, at a low level, the reason the classes exist is they're really just a reason to organize your stuff, right? It's just like a box. You can think of a class as being just sort of like a cardboard box, and you say, hey, I'm going to like put a label on it. I'm going to call it, my CD collection, or I'm going to call it my books, or whatever it is. And and I'm going to organize like things in and so when you looked at virtual machines before containers, they looked an awful lot like this. There's crap installed all over the place, and you don't really know what team installed what. And heaven forbid, like two different teams need the two different versions of Python. Got to do all sorts of random stuff in order to make sure that, similar runtimes but different versions could coexist together. Um, with containers, the world is just a lot more organized. And this goes not just for the applications that the teams are doing themselves, but also your daemons and all of your other stuff, right? If you have a security team that wants to focus on SSH, observability team that wants to focus on monitoring and logging, and then your applications, they all have their own little space and they all have their own little box, and they can put their stuff in it, and they know that nobody's going to mess around with their stuff, and they know that by installing their application, it won't mess around with anybody else's stuff either, right? So that's the other really huge thing, is that if you prior to the advent of containers, putting multiple teams or multiple different components onto a single machine was really, really painful. And so as a result, most people didn't. And so as a result, utilization of these machines was terrible, right? So it's not a very great economic proposition. Suddenly with containers, the ability to have these hermetically sealed boxes that are isolated from one another, you can pack them really tightly, drive up your utilization from 10% to maybe 50, 60, 70%. So 6x savings, which is huge for people, right? And then, I think that the other really powerful thing that a lot of people don't think about is like, what is that image registry API, right? Like, I think at this point, it's maybe a little bit hard to think about, but like 15 years ago, if you wanted to distribute your application around the world, you had to figure out how to do that. Are you going to put it up in a blob storage? Are you going to use FTP? Are you going to use hopefully SFTP? Are you going to use, any number of different technologies, BitTorrent, for spreading your application across the world? Now it's just solved. From your laptop, push a container image into the Azure Container Registry or any other container registry that exists out there. It's geo-distributed around the world. Go to any machine, anywhere, Docker pull, done, right? And I think that's the other thing that is valuable here, is to realize that there's a bunch of undifferentiated heavy lifting stuff that people just had to figure out how to do over and over and over again, that the container image comes along and just solves, right? And nobody really cares about this problem, right? Like, this was not a problem that anybody really loved solving. And so once there's a really good solution, everybody just uses it, to the point now, I think, where we're starting to see OCI registries be used for more than just container images. We're starting to see them being used as general purpose package storage and delivery. We've pushed WebAssembly binaries, we've pushed other kinds of stuff into these OCI registries, just because it's a great format for, or at least it's a good enough format for distributing things around the world. And then, of course, I mentioned this earlier, the last thing that this does that was actually the root of why all this tech was developed in the first place, is this runtime isolation, so that you can actually have production and interns all on the same virtual machine. What it importantly is not is security isolation, and I think this is a common misconception that a lot of people had, especially in the early days, but unfortunately still have. We can separate you from processor perspective, we can separate you from a memory perspective, but at the end of the day, those two applications are still sharing a kernel, and they are still processes in that operating system. And what I always like to say as a just sort of general rule of thumb is, if you don't trust somebody to give them a user on your machine, you probably shouldn't trust them to run a container on your machine. Or you probably shouldn't trust the container running on your machine, right? It's that level of coarse-grained, that level of security, right? And so it's great for a bunch of stuff. It's not great for hardware isolation. Sandboxes like WebAssembly, sandboxes like virtual machines with Kata containers, these can provide other tools for providing further isolation. And of course, security is very dependent on the specifics of your application, right? Obviously, some things need much, much more tighter security than others. So that gives you maybe the whirlwind tour of containers and why containers, and what Docker did. But I think you say like, well, hey, Brennan, you were really focused on this whole idea of Kubernetes and container orchestration. You barely mentioned it yet. And so, in 2013, what we saw was that Docker had done amazing stuff with the container, but it was focused on the machine. It was really focused on individual machines, running containers on individual machines. It wasn't thinking about the components of a distributed system. And I think what we were thinking about was, how do we go about taking all of these pieces that we see out there in the ecosystem and that we've used to build applications, and how do we build a minimally viable container orchestrator for what we're going to do? What we started with was this idea that we should decouple all the things. And this became an important design principle, I think, for both how we built Kubernetes and how we thought about API design. I think one of the fundamental API choices that you always have available to you is, when you group things together, does the group contain the things that are grouped, or is the group a pointer to the things that are grouped, right? In Kubernetes, everything is decoupled. So you have individual pods. They're not contained by a replica set. There's a replica set out there that points to a set of pods, but that replica set is completely decoupled from all of the pods. The deployment, many of you are probably even scratching your head and saying, replica set? I don't even know what a replica set is, because you don't even actually think about it. You think about it in terms of deployments, and then eventually pods, but actually there's this replica set in between that handles some of the version rollouts and stuff like that. But the deployment is totally decoupled from the replica sets, and they're totally decoupled from the pods, which also obviously enables you to have jobs that create pods, and stateful sets that create pods, and cron jobs that create pods, and daemon sets that create pods, and they all just create pods. And nobody in some sense knows where all those pods came from. They could have come from any of these objects that know how to create pods. And that decoupling is really powerful, because it means that I don't have to write a log controller for daemon sets and a log controller for cron jobs and a log controller for deployments. I can just write a log controller for pods. It works for all of them. So decoupling was an important part of the API as we were designing it. But we also wanted to bring in other concepts, right? And one of the concepts that one of the most important concepts that we wanted to bring in was this idea of naming and discovery. And this actually led to one of, maybe I would say, the more controversial decisions in the early days of Kubernetes. And that was the decision that every pod would have its own IP address. I think at this point, everybody's like, yeah, obviously every pod has its own IP address. But I will tell you, at the time, processes, and container is really just a process. Processes didn't have IP addresses, right? And so there was a lot of controversy around, like, first of all, how would you even implement this? And then secondly, like, how would you go about, why would you want to do this? And the reason is actually everything to do with naming and discovery. Because we really believed fundamentally that we wanted to use commonplace technologies. Specifically, we wanted to use DNS for naming and discovery. So every Kubernetes cluster ships with its own little DNS server. And the reason for doing that is because if you build your own naming and discovery service, you have to build clients for every single programming language that's out there to do the discovery, to do whatever it is. It's hard and painful to do that kind of work. But guess what works with every single programming language that's ever existed? DNS, right? And so, but of course, DNS only goes from a name to an IP address. It doesn't go from a name to an IP address and a port. And so in order to use DNS as our naming and discovery, we had to have every single thing that we wanted to discover have its own IP address. And as a result, every single pod had to have its own IP address. And I think it was the right decision. Ultimately, I think history has borne us out. And, I sort of, it's probably a little bit of hubris, but I say that it was sort of our iMac moment. I don't know how many of you remember when the first iMac shipped. I remember when the first iMac shipped. But when the first iMac shipped, it didn't have a floppy drive. And everybody was like, oh my God, it doesn't have a floppy drive. This is going to be a failure as a computer. All computers have floppy drives. And literally a year later, no computer had a floppy drive because the internet had happened and everybody very rapidly figured out, like, you just don't need floppy disks anymore. And I think the same thing was true with pods. It's like, we shipped Kubernetes 1.0 with this idea of the IP address attached to the pod, and everyone was like, oh my God, how are we going to make this work? The networking is hard. And like a year later, everyone was like, well, yeah, obviously every pod has an IP address. And that's an interesting moment, I think, in how we push things forward. One of the other things that was sort of fundamental and a little bit controversial in the discussions was this idea of hierarchy. So everything in Kubernetes is organized with labels. And the reason that everything is organized with labels and label queries instead of explicit lists, like you could imagine, we could have said, hey, for a service, all of the pods that are in a service, you place the pod into an array. And there's an array of load balanced endpoints. And when you hit the service, they go to this array of endpoints. But we didn't do that, partially because of the decoupling I was talking about, but partially also because we didn't want groupings to be explicit. We wanted them to be query based. We said, no, actually, your service has a label selector, and the label selector is run periodically, and it finds the pods that are attached, and then the IP addresses for those pods are used to dynamically populate the load balancer. There is actually an endpoints object, but it's very hidden. You have to go looking for it if you want to go find it. And it's dynamically repopulated periodically. And again, the whole idea of this was to switch from explicit groups to implicit groups. And the value of this becomes, it's very, very easy for things to enter and leave the groups. You don't have to maintain a mapping from, these pods to these IP addresses or anything else like that. You just have to have this semantic label. And if you want to remove something from a load balancer, you remove the label from the pod. It just fits together in a very clean way. And this meant a lot about like how we wanted to organize things in general based on labels, tags, annotations, rather than explicit groups of things. Getting into the details of how we did it, one of the things we were really focused on was this idea of it being born in the cloud. Obviously Kubernetes runs on premise. I have a little Kubernetes cluster here under my desk. But it really in its heart wants to be in the cloud. It wants to use dynamic APIs. It wants to be able to create load balancers. It wants to call and attach disks and detach disks. There's a lot of different stuff. It just assumes that there's a public cloud API sitting out there for it. Another thing that was actually pretty controversial, like surprisingly in retrospect, but was that it had to be open source. This was actually quite controversial. I spent a solid 6 months of my life arguing for the fact that Kubernetes should be open source, and really the only way that it should be successful or could be successful would be if it was open source. it's interesting to look back in retrospect. I think there's this tendency, especially in sort of people who are focused on a business, perhaps, of wanting to control everything. And obviously, like, if you can create something that's as popular as Kubernetes has turned out to be, and you have complete control over it, and it's only in your cloud, that's a very, very awesome place to be. Unfortunately, it's not a possible place to be. And this was kind of the argument that we had to make over and over and over again to people. People would say, like, well, but don't you want it to just exclusively be something that people can use in our cloud? And we would say, well, but the thing is, someone else will build something that's open source and it will win. So you don't get to choose to win and be private. You don't get to choose to win and be proprietary. The only path to winning is open source. And of course, by being open source, you're going to lose some control, but you will win. And that's the choice, right? And I think sometimes it's hard for people to really get to that pragmatic level where they say, like, oh, I don't get to choose the point that is perfect for me. I can only choose the point that's good enough. But eventually we got there, and we did manage to open source it. And of course, the last thing we had to do before we open sourced it was give it a name. And many people maybe have heard the story of the name before. I won't bore you too much with this. The original distributed systems that I had used was a system called Borg. When we started working on Kubernetes, I named the project 7 of 9 because 7 of 9 is a Borg from Star Trek Voyager, which is, if you watched it, and it's not the best Star Trek show, although I enjoyed it. But 7 of 9 is the more user-friendly Borg, because she's been, captured by humans and made to be friendly. And that didn't work because of trademark reasons. And then we shortened it down to Project 7, which I actually really liked and wish we could have launched as Project 7, but it turns out someone else had trademark on it. And so eventually, like literally a week before we were shipping, Craig was like, how about this Kubernetes thing? And that's what it became. But if you look closely at the wheel and the shape around the Kubernetes wheel, it's 7-sided as a shout back to Project 7 and 7 of 9. So that's the inside story of the logo and the name. All right. So it's 10 years later. And I've gotten older, although perhaps not as gray as this fellow who's from an Indiana Jones movie. So at this point, Kubernetes is a commodity, and people have said for years now that, like, we're trying to make Kubernetes boring, or it's supposed to disappear into the background. It's just sort of something that it's like learning about x86 architecture, right? You're probably like, well, I learned about that thing sometime in my undergraduate, and I guess I use it, so that's cool. But like, what are we really doing? So what does it mean really that this thing is a community, or excuse me, that this thing is a commodity? I think one of the most interesting things that we've seen is that platform as a service is traditionally seen has kind of, the momentum around things like Ruby on Rails or Cloud Foundry or Heroku or any of these systems, like, has kind of faded. I would say even the momentum around something like functions as a service has kind of faded a little bit. And I think it's because, there was a lot of problems that those systems were trying to solve, and Kubernetes probably solved 75% of them without forcing you to give up much freedom. Whereas those platform as a service, they solve a lot of problems, but they force you to give up a lot of freedom. But the interesting thing is that doesn't mean that platform as a service is actually really dead. It just means that it's being restructured. Because if we think about, like, well, what is platform as a service? It's kind of packaging, deployment, reliability, and developer experience. And if you look closely, I would say that when you look at Kubernetes takes care of 3 of those. Takes care of packaging, well, really container images and Docker build take care of packaging. Kubernetes takes care of deployment. It takes care of reliability. I mean, I put reliability in quotes, but it takes care of at least restarting your container if your container fails. And if you set up auto scaling and things like that, it will take care of auto scaling up and down for you. And what's left then that it really doesn't do anything for at all is developer experience. And so then I think what we're seeing is the reconstructing of kind of a new form of platform where, and I think people are starting to call this platform engineering, although I'm not sure that I love that term, where people say like, oh, you want functions as a service? There's like 20 different functions as a service that you could choose to put on top of the Kubernetes API. And more coming every day, right? And I think this is a testament to just how easy it is to build a platform on top of Kubernetes. Like the fact that everybody is sort of like, oh, cool, I built functions as a service shows it's really not that hard to do once you have containers in the Kubernetes API. Similarly, and I think probably also because of recent news of the acquisition of VMware, people are starting to say like, well, wait a minute, like this whole Cloud Foundry thing, I want to figure out how I run that on top of Kubernetes and I don't have to, take on a whole big support contract in order to do so. We've seen big data come across to run things like Spark, and obviously all of the AI inference and training that OpenAI does is using Kubernetes on top of Azure. So ChatGPT runs on top of Kubernetes, runs on top of Azure for all of their training and inference. And then finally, like whatever your platform, however you want to build your platform, people are doing a whole bunch of that as well. So taking stuff off the shelf, taking former platforms and refactoring them, doing big data, building their own, and of course, they're still doing vanilla APIs as well. What's important about all of this is that things like service discovery, things like the container image format, all of those kinds of common things are shared across all of these things. And so you only need to figure out how to build containers once. You only need one secure supply chain. You only need one way of doing service discovery. You only need one logging system. You only need one monitoring system. There's a lot of common ground that happens when you're built on top of this shared foundation. And the net result of that is you're freed up to do some pretty fancy things, right? So, I think that the whole, one of the things that this is the Falcon rocket, before SpaceX said, hey, we're going to reuse these rockets, people just like tossed them in the ocean and built a new rocket, right? There was no foundation that you could build upon. SpaceX comes along and says, no, that's really actually a dumb idea. We're going to reuse our rockets across a bunch of launches. All of the work, it's not that SpaceX knew how to build rockets cheaper than NASA knew how to build rockets. It was saying, hey, let's reuse some effort across a bunch of different platforms in order to save our money and not have to rebuild stuff every single time. And I think the same thing is true in these distributed systems, right? It's not that people didn't know how to build things on top of virtual machines or on top of real physical machines. It's that if you take the Kubernetes API and you lay it underneath a lot of these nice to use platforms, you get to reuse a bunch of effort over and over and over again, and that leads to more efficient systems, more efficient construction of these things. So what are we trying to do here? Like the goal from the beginning, from the day one when I started, was to democratize distributed systems. I think it's awesome that we've managed to build up this Kubernetes API that has made it easier for people to maintain these distributed systems. But I would say I'm actually kind of sad that we've never actually really made it that much easier to build them. And it's hard for me to know exactly why. I mean, some things have gotten easier, a few things have gotten easier here and there, but I don't think we've really made it dramatically easier to build distributed systems. And I think it's because we haven't really approached what goes into the cluster as if we were building a distributed systems environment or an operating systems environment. And this is kind of what I mean, right? Like, we haven't focused a ton of effort on automating common tasks. There's a few examples here and there. I hope everybody's using something like Cert Manager to manage their certificates. I hope everybody's using a monitoring system that understands Kubernetes in order to monitor their applications automatically. But honestly, like, even if you are, that's barely scratching the surface of the best practices that you could install on your cluster. And we do a really bad job in most cases of being able to reuse standardized implementations and standardized patterns. I think we still have a very, very bad tendency to rebuild from scratch our distributed systems every single time, right? And we don't use concepts. We basically, I mean, it's as if I tell people, like, it's as if we were asking our distributed systems engineers to re-implement sorting algorithms every single time they wanted to sort things. If you got a PR from someone and they had re-implemented sort, you would reject the PR. You would say, there's a library right over there. Use that function. Don't write your own implementation of sort. And yet every single day we're effectively doing the same thing in these distributed systems, whether it's with caching or with distributed locking or many of these other concepts that would be really useful, and that we force people to do over and over again. I want to be mindful of time, and so I'm going to jump ahead a little bit to talk through the final piece of this thing that I would love to see us do, and then a little bit about a system that I think helps. The first thing that I wanted to talk about is this idea of intent-based APIs. I want people to start thinking about this because I don't think that we are doing a good enough job. Operators have sort of come along and done some of this stuff, but again, I don't think that it is as conceptual, right? I think people have built some APIs, but they're all single level. They don't compose well together. They haven't been thought out like you build an operating system. And an example of this would be something like a load test API, right? What if you could just walk up to your Kubernetes cluster and say, hey, please load test my thing? And it just happened for you. There are some operators out there that will sort of do it for you, sort of. That will use Locust or otherwise to kind of do it for you. But I think that it's something you still have to install. It's not something that I, as a cluster operator, think, hey, every cluster that I ever create should just have the ability to load test something. It's something that I, as a developer, have to figure out on my own, maybe with the right how-tos or things like that, install onto my cluster myself, do a bunch of work. And there's lots and lots of examples of this, right? Like we're still at the level of like almost like a DOS prompt. If you're going to take a operating system analogy, I think that the average Kubernetes cluster is basically like a DOS prompt. And we all know that like there's a lot of better as you get towards Windows and other operating systems. Like there's way better operating systems out there than just being at a command line for getting things done, right? In terms of utility and in terms of services, right? Like if I'm still in DOS, I have to write my own printer drivers, I have to write my own mouse drivers, I have to do all this stuff myself. And that's what we're forcing developers to do in Kubernetes today. And so like the one place where we've managed to make a little bit of traction here, I think, is this system called Dapper that we've been working on recently within AKS. And actually, there's some similar ideas that we're working on in the WebAssembly space with Wazi Cloud, which is sort of a standardized interface for talking to cloud services. The basic idea behind Dapper is this notion that we're going to have a user application and a co-process. User application talks to the co-process as gRPC. These exist inside of a Kubernetes pod. And like this is, I think, hopefully shows you just how easy it can be to do something with this sidecar. This stores a value into a NoSQL store. What are the things you see that are missing here? Well, there's no HTTPS, there's no authentication, there's no client library that I had to import. And you would say like, well, I mean, doesn't that just mean that you're insecure and your thing doesn't really work? And the answer is no, actually. It's still secure because remember, this communication isn't going to my storage service. It's going to that cloud co-process over local net where I don't need encryption. And then the Dapper co-process is taking responsibility for pushing that data up to the cloud using authentication, using encryption, and using a client library. So that means that I, as a user, just think about making raw HTTP requests, and the co-process can handle security, can handle client dependencies, which in this world of secure supply chain are becoming increasingly a risk, and can also handle best practice implementations of sharding and everything else like that. So this idea of being able to sort of split your application out into a set of libraries that we share across polyglot applications, and your user code, I think, is a good pattern to take forward. It's also really important, I think, because the truth is that we can imagine amazing things, but if it doesn't work with giant legacy programs, like J2EE or ASP.NET talking to legacy databases, it's just not going to work, right? And so the nice thing about Dapper is it's incrementally adoptable. You can make it run with your old school J2EE application that mostly talks to a SQL instance. And then as you add new capabilities, use the Dapper sidecar for those new capabilities. It's also very polyglot, doesn't really care if you're using Java or TypeScript or Python or .NET or whatever else. And it has components for a lot of common stuff like storage and secrets, events and authentication and more. And of course, anything that we do, it's open source. It's actually been donated to the CNCF. It's moving its way up through the CNCF and seeing actually a ton of adoption. And so come, if you're interested, check us out at dapper.io or GitHub Dapper. Check us out at KubeCon if you ever happen to be there. But more generally, I hope, that you can think a little bit more about like, how do we build shared componentry for distributed systems and avoid having to reinvent the wheel every single time we sit down to build something new. And with that, I'm pretty much at time. And I wanted to say thank you for having me. And I'm happy to answer any questions that you might have. And I will stop my screen share.
All right, thank you, Brandon, for that wonderful presentation. It's fascinating to see the history of virtualization technology and how the container Kubernetes continue to evolve to drive innovation in the cloud. All right, so now let's open the floor for audio questions. I see a queue of questions in the document, but I'd like to give a chance to everyone. You can unmute yourself or raise your hands in the Zoom so we can hear your voice. Yeah, feel free to unmute yourself and ask questions directly.
I have a question regarding the service called container instance in Azure. Do you mind introduce a little bit on that, like,
Yeah,
or
sure.
how? Yeah.
Yeah, so I mean, I think of container instances as being a primitive, a serverless container, if you will. I think serverless got kind of tangled up with things like Lambda and the functions as a service programming model, but I don't think serverless has to mean functions as a service. And so I think container instances are really there to provide you with something that runs a container, but there's no operating system, there's no node anywhere, there's no machine anywhere. And we've done a bunch of work to integrate that with the Kubernetes orchestration APIs with virtual nodes and the virtual kubelet. I think this is an area actually where the Kubernetes community itself hasn't done as much as it maybe should to figure out what does it mean for Kubernetes to manage serverless containers? Because obviously container instances isn't the only technology. There's Fargate in AWS. VMware has some stuff. Other people have built other stuff that are similar. And yet I would say that Kubernetes as a container orchestrator is still pretty deeply attached to managing machines. I think Kubernetes at its core still thinks of itself as a machine orchestrator, not a container orchestrator. It's a machine orchestrator that happens to then put containers on the machines. I think that philosophy has to change at some level, but it's been a hard conversation to get a consensus about how that might change and what it might look like. So that's sort of, yeah. Go ahead.
You meaning right now Kubernetes seems not working so well with container instance, that case.
It's not native, right? We've had to do a bunch of stuff on the side in order to make it work with
on top of container instance, maybe.
On top of container instances and outside of the core Kubernetes components, right? The virtual node integration exists outside of Kubernetes. Kubernetes itself doesn't understand serverless containers.
I see.
And in the past, and it's been a while, and maybe it's worth revisiting. In the past, when we've sort of brought it up as an architectural change to think about, people have not been very interested in pursuing it in the community. So I think there continues to be room to work on it. So yeah.
So Azure also has some service called virtual nodes? you mean?
Virtual nodes are a part of AKS. So virtual nodes are the thing that bind Kubernetes to ACI.
I see.
Container instances. So
Mm-hmm.
it's called a virtual node because it looks like a node, and if you do kube control get nodes, you'll see that node, but it doesn't really exist.
I see. Yeah. Thanks a lot.
Yep.
Yeah.
Yep.
All right. We have time for more questions. Long way.
Yeah. Hi. I guess it's just a pick story from the queue that I put in here. Actually, my question is really from, I guess, non-tech section, like really from banking, that really just the user of the Kubernetes, the whole ecosystem, beyond speaking, is quite complicated. And like internally, we have team that want to move to Kubernetes, and we have team that are already on Kubernetes and want to move back to more like a just let other people host it, like by managed services. My question is really like, do you think there will be a higher abstractions on this Kubernetes, or a different what's it thinking model or thought or models that can better describe or better attack those kind of distributed system? Because it seems like you say, it is community or we think like a utility, but at this point, I don't think just like we just use it without too many thinking or tinkering. It requires a lot of manpower to really maintain a cluster up and running. That's my question. Like, whether there's a higher level abstraction, and what if it is, what will it look like?
Yeah, I mean, I definitely think you're right. Most teams, most people don't want to absorb the complexity. And I think that's where some of the platform engineering that's been talked about lately has come from, where you might have a platform team within a company and they deliver a much simplified experience that may hide Kubernetes entirely. It may hide Kubernetes partially. I think, the providers are also working to make it easier. With Azure Kubernetes, we're doing a lot of work to, turn on auto upgrade and turn on auto scale and turn on a bunch of stuff that makes it so that you don't really have to manage anything, as well as, doing things like creating GitHub actions for you so that, if you push code into a repository, it will automatically deploy that code out to your cluster, and you may not even think very hard about where you're running it. I think your question of whether it's a higher level of abstraction or it's a totally different system is still to be determined. I think no one has yet figured out something that has managed to have an equal level of popularity. And I don't necessarily know why that's true, but it is true. And so I think, people are going to continue to try and do this sort of platform engineering work and try and find abstractions that work well, and that can be shared and that can be reused. And we'll have to just sort of wait and see, like, if that looks like something that's built on top or it's something that just completely hides the details. I'm kind of betting, I would say I'm betting on Kubernetes to stick around, but I'm probably a little bit biased. And I could imagine scenarios in which it disappears.
Thank you.
Awesome. Yeah, John.
Hey, thank you, Brandon. This is an excellent talk. I'm not going to ask a specific technical question. I'm curious, how did you drive Kubernetes, such a successful technology, from like a prototype to this success? It's more like a personal impact, influence, and growth question.
Yeah, I mean, I think so. One thing I will say is I gave a talk kind of on this for I think it was the GitHub Contributor Summit a while back, so you might be able to find that on YouTube. But just to sort of sum it up, I think there's different phases, right? So in the early phases, it's a lot about creating a vision, like creating imagination, because you need to rally people around you. And in order to rally people around you, they have to imagine where you're going. They have to be able to see it either through demos, even if they're not 100%, even if they're not where you are today, but where you want to go, or other kinds of storytelling. You have to craft that vision about where you want people to go, because otherwise they won't gravitate towards you. And then, once you have that critical mass, it's about how do you move well at scale. And we did a lot of really good work, I think, early on, decentralizing and getting individual owners of special interest groups or individual owners of specific directories and really delegating a lot of power. I think Joe and Craig and I never set out to be in charge. And I think that really helped us spread the load a lot, which in turn enabled us to move really, really fast, because we didn't have to bottleneck on one single decision maker or one, a small group of decision makers. We gave people the power to move independently. That's, again, that decoupling helped a lot with that. And then I think as the industry turned, there was a lot of really interesting stuff around how do we do code of conduct? How do we write governance? How do we do all this kind of how do we build a foundation that was about how do we make sure that this thing stays as an independent entity, not something that any one group of people take control of. So there's and that was interesting and hard too, because nobody had really done that. So there's a lot of looking at examples from other places, a lot of talking to other people, a lot of asking a lot of questions. I think those were all those different phases of how you do it. I would say I view it sort of like building a fire. Like in the early days of building a fire, you're really careful about what piece of wood you put. You choose each piece of wood very carefully. You place it very, very carefully. And then at a point, it's this raging inferno, and you can throw whatever you want on it, and it burns. And then at some point, you think, "Oh my God, maybe it shouldn't get any bigger, right? Don't get it close to the house or whatever, right?" And you're thinking about safety and governance and control, and so there's all sorts of different phases that you go through. But a lot of learning, a lot of delegation of authority, delegation of power, and finding great people who could help.
Thank you. Got it. Thank you.
Thanks. We just want to be mindful about time. We take one more questions from the audience. Roger?
Roger. Thanks, Brandon, for such wonderful talk. I have a question, more technical related. Inside of Microsoft, most of the database services, they are hosting on Service Fabric. And across the industry, I don't actually see many database services, hosting on Kubernetes. So do you have any visions or any roadmaps or plans to broaden the Kubernetes, maybe on the stateful services or databases?
Sure. I think there are plenty of cloud native-ish databases that have been built for Kubernetes and that run on Kubernetes, stateful services that run on Kubernetes. I'd also say I think a lot of traditional databases don't run, they weren't built to run in containers. And your best bet probably is to run them on a big beefy virtual machine or a couple of virtual machines. A lot of those databases, they just want to take over the entire machine, and that's the best way to run them at scale. And I don't think that containers and container orchestration is necessarily, you have to do everything in them, right? I think sometimes you say look, this is just a better fit for a different piece of technology. And legacy plays a role too, right? You mentioned Service Fabric. I think a lot of the stuff that's on Service Fabric, was built a long time ago, and was built in in a world where that. And then Service Fabric also focuses really heavily on data, and the needs of data. So I guess my feeling is I in some sense I view Kubernetes as agnostic technology, and if you can use it to run stateful stuff, great. If it needs stuff to help you run stateful stuff, that's where stateful sets came from, is the needs of people running stateful stuff. the community may look to add that stuff, but I never really would go out and be like, oh my gosh, I need every single workload to be on top of a Kubernetes cluster. And frankly, I think actually for a lot of these storage services, like you're better off consuming it from the cloud anyway. I don't really like running stateful services myself. I'd rather buy somebody else's.
I see. Thank you. Yeah, because a lot of these stateful services, they are like a customized run. It's not running in containers like you said. So that's probably they choose like maybe some
Well,
I
I think also a lot of them at scale, like the needs become like storage services at large scale almost become orchestration systems unto themselves. Right, where having a general purpose orchestrator underneath a storage level orchestrator just may not make sense. So I have got a little bit of time, and I see there's only one person. I feel bad like not answering June's question. So like let's bring it on.
All right, thank you so much.
Oh
June,
yeah,
go ahead.
Oh, so my turn. Oh, okay, thank you. So I'm working on hybrid cloud environment. So I wonder, so I have to deploy like multiple Kubernetes to deploy into different cloud providers. So I wonder if like Kubernetes control plane can manage other Kubernetes control plane like data planes instead of like the flat network you mentioned. Is that can be more flexible in topology. So
yeah. I mean, I think when you look at like what AKS Fleet Manager is trying to do with Azure Kubernetes Service, it provides a cluster, a management cluster that can then manage other clusters. And I think we're thinking about we're going to bring that to hybrid environments as well. And I think if you look at I'm blanking on the name, but there's another control plane that people have built, Crossplane. So Crossplane is a project that it's more than just managing other clusters, but it's a Kubernetes API server that then knows how to manage other kinds of resources. So you could probably look at that for managing multiple clusters across multiple clouds. But yeah, that kind of like meta level management is a challenge. It's interesting. It's a problem. I mean, like literally right after we got to Kubernetes 1.0, people started talking about Kubernetes federation and how do I build federations of clouds or of clusters. It's never really taken off.
Yeah.
Right. And I always think those problems are always super interesting because like if people have been thinking about it for 10 years, but like a solution that everybody likes hasn't really emerged, like that means it's actually probably a hard problem. So
okay, thank you.
yeah.
All right, we are tight in time. Well, thank you, Brandon. One last question from me to all the audience is what one piece of advice would you give to people who are aspiring to be an expertise in this field like you?
Oh man, I guess I would say go find the things that you're interested in and don't worry about where they take you. Because I think being excited and interested in the stuff that you're working on gives you so much more energy to pursue it at depth than like, if everybody's focused on AI, but you think AI is boring and you want to learn about kernel internals, like go learn about kernel internals, right? Because it'll be exciting and you'll become a better expert at that than trying to learn about something that you don't find interesting. That's probably the best thing that I would say. Like I've had a variety of different experiences and somehow they've all kind of come back together to help with what I did next. And so getting that diversity of experience, I think is really great. Listen to other people. I've learned so much from other people, even to the day. So, I'm not, yeah, that's hopefully that helps. I don't know. I always get a little, I don't, yeah.
Well said. Thank you.
Yeah, thanks. And thanks for having me. It's great to chat. And apologies to people if I didn't get to all the questions. So
great.
All right.
To extend a big thank you to everyone who joined today. And well, have a good evening.
Yeah, take care. Good night.